Hello, Mr.
Oh,
How are you today?
Hi, Mr.
Hello, Mister. How are you?
okay.
Fine. What about you?
Yes, thanks, my students. Thanks. Thanks, Omar. Anyone is ready now for the experiment, my students? But after 2 minutes, we begin. Just a minute. We will begin after 1. Please, my students, lower your hands. Assalamu alaikum wa rahmatullahi wa barakatuh. My students for grade 3. I wish you a good health. With you, Mr. Ashraf Ahmad International Schools. Today we'll study high and low tides. You go to a beach a lot. You will find that there is water go up and go down in the beach. That is the beach here. Do you see? Tides here are changes in the height of ocean water. Mean it will up or will down. Gravity causes ocean tides. When the money above an ocean, it causes high tide on the part of Earth and the opposite side too. In the part of the ocean between the two areas of high tide, the water level is lower. There is a high tide into where have the people come, they didn't want to get wet was high tide, you know? That is the tide and ebb here, okay? At most beaches, there are high tides and low tides every day. The tide make a cycle. Before we saw people walking on the beaches covered with water. But we want to know now what is the tide. We want to know now what is the tide first. Before I just what is the tide? What is the high and low? We, all of you, inshallah, go to the beach. You will see the tide changing in the height of ocean water. Underline it, please. We have the high tide and we my students. That's what we see. Okay, but first I want to listen, okay, to something about the students, about tides and about the motion first. Anyone is ready, raise your hand. Not ready, lower your hand. Or is lower, I want just the experiment today. Or if you lower your hand, I want just one who is ready for the experiment today. Abdullah Ammar, are you ready?
Yes, Mr. Today I am so much ready for the new experiment that I'm going to make today.
Have experiment today?
Yeah, I have the water cycle today. I'm going to make it. Maybe at 7 o'clock or 8 o'clock. I'm going to make it.
Yeah, no problem. Okay, thanks. So have an experiment? Okay, thanks. Karim Adel?
What is the new experiment?
Mister.
If you want to make no problem. I see you raise your hand, okay?
What?
You don't have, okay, no problem.
Mister.
Okay, no problem. Yes.
Mister, can
Thank you. Bye.
1 minute. Okay, Ahmed Fawzi, you have one?
Yes.
Mister, hi.
Today?
I'm talking with
Today or after?
I will do it, but I want to talk about it.
No, I want to do it.
I want to talk about it, and then I'll do it.
Okay, no problem. You can talk. No problem.
I'm gonna make a volcano.
Yes.
A volcano. I will wrap foil around a bottle of Coca-Cola and put Mentos in it, and an explosion will happen.
That's a good idea. Inshallah. That's a very good idea. Thanks, Ahmed. Okay, but if you make it practical, you make activity, okay, it is okay. Thanks, Ahmed. Tayyim, you have any new idea today? Tayyim?
Hello,
Amr Ibrahim, you want a new idea?
Of course.
Okay. You have now?
Yes, I have now. I can talk about it now. I will do it now.
Yes, can you open the camera, or I take share for you, stop share and you will share?
I wanted to talk only without the camera or share.
Okay, talk, but send to me my private sub your work, okay?
Okay.
Okay, no problem.
Okay, I will make it now.
Yeah, no problem. Okay, talk about. I'm listening.
Is a world of weather. Earth is surrounded by a layer of gases. This layer of gases is Earth's atmosphere. Oxygen is one of the gases in Earth's atmosphere. Most living things need oxygen to survive. Water vapor is another type of the gas in Earth's atmosphere. Conditions in the atmosphere can change. Weather is the condition of the atmosphere at any one place and time. If the atmosphere over your school is warm and dry, in the morning your weather is warm and dry. But the atmosphere and your weather could change. The weather could be cool and rainy by the afternoon. Types of clouds. There are many types of clouds. Each type of cloud has a different shape. The type of cloud in the sky can tell you what kind of weather may be coming. The first type of cloud, this cloud is cumulonimbus. These clouds are often tall and have a flat top. They sometimes look like mushrooms and often produce thunderstorms. The second type of cloud is cirrus clouds. Cirrus clouds are thin and feathery. Cirrus clouds are high up in the atmosphere where temperatures are cold. They are often a sign that the weather is about to change. Cumulus clouds have flat bottoms and are puffy on top. They look like piles of cotton. Cumulus clouds usually mean fair weather, but they can develop into cumulonimbus clouds. Stratus clouds look like thin blankets. Often they hang low in the atmosphere. Stratus cloud can mean the light, rain, or snow is coming. I finish now.
Thanks, Amr. A good idea, but I want you to make a model, for example. You make an idea, okay, but you make it by your hand, okay, Amr?
Okay,
try. But that's a good idea. Well, inshallah, a good experiment. Today we are talking about, Amr, about tides. Tides changing the height of the ocean, maybe up, maybe down. Maybe it will be go up high tide, go down it will be low tide. But the reason of this, the pull of the moon of gravity. So we talk about the motion of the moon today in details. Follow me to give me any idea about the motion of the moon. Okay, we'll begin. If you don't hear well, just raise your hand, okay? Now we will listen all.
Imagine if you could watch the moon over the course of several weeks. You would see that light would...
Ahmed Fawzi, do you hear or no?
What?
Do you hear well?
Yes, I hear.
Okay, Ahmed. Okay, listen with the students.
Gradually be added to the face of the moon, and then after reaching the full phase, the light would seem to come off. So these are the familiar phases of the moon. Now, before we describe the phases of the moon, let's just clarify one rather important point about the moon, and that is we always see the same side of the moon. It doesn't matter what phase it's in. If you look at the features on the moon's surface, we're always seeing the same near side of the moon. So a really good way to compare the near side and the far side is to look at them side by side. You notice that the near side has these light regions, but also many darker regions. These are known as mare, and the far side is dominated by highland regions. So the question now is, why do we only see one side? Well, we will eventually learn that this all has to do with something called tidal forces. But practically, what does it mean to only see just one side of the moon? Let's take a simple illustration. I've rendered the moon with the far side in gold and the near side just as the normal coloring of the moon. So we have the Earth at the center, the moon revolving around the Earth, but we're going to let the moon stay still. In other words, we're letting the moon revolve, but we're not allowing it to rotate on its axis. So if the moon doesn't rotate on its
Yes, mister. Yes, mister. Mister, why you mute yourself?
I'm asking. You hear well?
Yeah, I hear.
You hear well, that's okay. The video is okay, you hear or you don't hear?
I hear well.
Okay, no problem. Okay. Thanks. Continue, my students. Okay.
Of about a month or so, we should expect to see all sides of the moon, both the near side and the far side. On the other hand, if the moon executed several rotations on its axis as it revolved around the Earth once, then we would also be able to see both the near and far sides of the moon. So how is it that we can only just see the near side of the moon no matter where it is in its revolution around the Earth? And the answer is timing. The rotation period is exactly equal to its orbital period. So you see that as the moon is revolving around the Earth, the moon is also executing a single rotation on its axis. And this keeps the near side of the moon facing the Earth throughout the entire lunar orbit. And we call this type of rotation synchronous rotation. And it's for this reason that we always see the same side of the moon facing the Earth. Therefore, the far side, by definition, is forever hidden from our view. As we saw in the previous images, if we wanted to actually view the far side of the moon, you have to go there, or at least send a spacecraft there to take a picture and send it back. Now let's take a more realistic view here. So we're going to put ourselves in space, and you notice that we
Okay, my students, just now we will talk about the moon phases. We have many phases of the moon. That is the rotation of the moon around the Earth. My students. So when I ask what are the phases of the moon, okay, Amr Ibrahim, what are the phases of the moon, Amr?
Yes, mister.
What are the phases of the moon? Said.
The phases of the moon.
Yes.
have both the Earth and
You have new moon. Okay, listen, no problem. No problem. Listen, Amr, then you can. No problem. Listen.
the moon has a daytime side and a nighttime side. But as the moon executes its rotation around the Earth, we can only see at any given time a portion of the near side because of the illumination from the sun. So let's just imagine for a moment you're standing on the Earth and you're looking toward the incoming sunlight. And suppose the moon just happens to be between the Earth and the Sun in this case. So we're looking at that first image of the moon that is to the right of the Earth. If we were to look up, take a look at the moon and somehow squint and be able to actually see the moon, which we never could really expect to do, we wouldn't see a moon. The moon would be in silhouette, and we call this phase of the moon the new moon phase. Likewise, the appearance of the moon is purely the result of where it happens to be in its orbit with respect to the incoming sunlight. And so you notice that the phases where the light is being added to the moon, we call those the waxing phases. Whereas when the light is being removed from the moon, we call those the waning phases. So we have waxing crescent through first quarter to waxing gibbous to full, and then we repeat the cycle, but we reverse it. We go from gibbous to third quarter to crescent and then back to new again. So let's imagine that we are now standing in place of the Earth, and that is the main view that we see here. We're starting out with the moon between us and the sun, so therefore this is new. If you look at the inset on the lower left of your image, we have the Earth and moon, obviously not to scale, but certainly within the same configuration. We have the Earth and then we have the moon, and you could see the sunlight is illuminating both the Earth and the moon, and the sunlight would be coming in from the right. So let's begin the movie. Let's just watch the moon revolve around the Earth through one complete lunar cycle. So here we're in the new phase. We simply don't see the moon, but you notice that as the moon makes its way to about the 1 or 2 o'clock position in the inset, we're beginning to see just a little sliver of that illuminated side. So this is the waxing crescent. Now, when the moon gets to about 1/4 of the way around in its revolution around the Earth, we call this phase first quarter. A lot of times people call this the half moon, but in fact we're seeing just, well, 1/4 of the moon's entire surface. So the moon is continuing to move beyond first quarter. It's not quite full. We call this phase waxing gibbous. Now you see as the moon is coming around to basically opposite the Earth from the sun, we can now see the entire illuminated near side of the moon, or rather the entire near side of the moon is fully illuminated. We call that the full moon phase. So as the moon begins to come around, it's losing some of that light as seen from Earth. We call this waning gibbous. And as the moon makes its way about 3/4 of the way around in its orbit, we give it an unimaginative name of third quarter. So the moon has gone 3/4 of the way around in its orbit, and we are seeing just 1/2 of the near side of the moon. So if you look carefully, you'll see that there still is this appear, it's just that it's in silhouette. So now we're in waxing crescent, and the light continues to wane off the moon, so to speak, as seen from Earth, until we eventually come around and we lose the very limb of the illuminated side, and we're back to a new moon phase once again. Now, as we think about how long this takes, well, the answer is it's about a month, but about a month is really the key phrase here. Let's explain how this works. So we have a diagram of the Earth and moon, and we see the Earth's orbit illustrated, we see the sun. And I'm also going to vernal equinox, and we're just going to imagine the vernal equinox as a fixed location among the stars, and we will be able to measure our position relative to the vernal equinox no matter where we are in our orbit. So in this illustration, I've chosen to place the moon on the left, and that would mean that we're looking at the moon and we see the fully illuminated side of the near side of the moon. So we have the full moon, of course. But imagine what would happen if the moon were to make one revolution around the Earth. Well, it can do that, but at the same time, the Earth is also moving about its own revolution around the sun. So when the moon comes back to its starting location with respect to the vernal equinox, it isn't quite full yet. It's almost full, but it's not quite full. It's now a waxing gibbous phase moon. So this period of time is called a sidereal month, and sidereal literally means the stars. So this is a month with respect to the stars. It allows the moon to make one full revolution around the Earth. This comes out to about 27 1/3 days. That means if we want to get back to our starting phase, which in this case was the full moon, well, then we have to allow the moon to orbit and indeed the Earth to orbit a little bit more. So we need a couple of extra days of motion, and this gives us what's called a synodic month or a solar month, literally with respect to the sun. So this is what gets the moon back to the starting phase. And it wouldn't matter if we chose the new moon phase as our start phase or first quarter phase as our start phase. From any given phase to any given phase, it's going to take 29.5 days to get there. So there's a difference. When we say a month, the first question we have to ask ourselves is, well, what do we mean by month? So let's imagine the phases. Now we're going to take a split screen view, you might say. We have the Earth and the moon on the left. We have the phase of the moon as it appears on the right. And you notice I've drawn a symbol representing the direction to the sun and a second symbol representing the direction to the vernal equinox. So we start out with the new phase and we proceed to the waxing crescent we saw. And again, we're just repeating what we saw before, but with a slightly better understanding of how these phases evolve and the sequence of the phase. So the main reason for the phase is simply an alignment or a geometric view of the moon with respect to where it happens to be with respect to the sun. So let's put all this together, and now we're going to imagine ourselves looking at the moon. I'm using stellarium, and I've zoomed out to a very wide field of view, which is way beyond what the human eye normally sees. The moon and the sun are going to be very tiny in the sky, so I correct for that by enlarging the moon by about 10 times. Now let's take a look at our inset. So this is an overhead view. We're kind of looking at this slightly in perspective. Our hometown of Baltimore is right there, and that means that north is toward the top of the globe, south is toward the bottom, east and west to the right and left accordingly. So because the Earth is rotating on its axis, that means that the sunlight is coming in from the direct, and that means that given our location, we're kind of rotating from the night side of the Earth into the daylight. We are therefore experiencing dawn. And so the sun is exactly where we expect it to be. It's on the eastern horizon, it's just rising. And because the moon is between the Earth and the sun, the moon is presently at the new phase. So we have our vernal equinox. We know that the Earth is going to continue in its orbit as the moon revolves around the Earth, and we're seeing the moon in the new phase. By the way, I've just gone ahead and just added that dotted line just to help us see the moon. Let's go ahead and get the movie started, and we'll just watch and see what happens. So we notice that the Earth is rotating. It's carrying us from the daylit side to the nighttime, and we come back to a new day. But because the moon has traveled a little bit in its orbit, the moon is now somewhat east of the sun, and you could just see it setting just after sunset, and we are now in the waxing crescent phase. So we're going to let some more time go by. We're still well within waxing crescent. And as we get closer to first quarter, you're going to notice that the moon is rising later and later and later. So much so that by the time the first quarter phase actually arrives, the sun will be on the meridian just as the first quarter moon is rising. Let's take a look. So there's the sun on the meridian and the first quarter moon just rose. So that means when the sun sets, the first quarter moon's on the meridian, and then the first quarter moon sets around midnight. So now we're getting into the waxing gibbous phases. So we're going to let the moon just keep moving right along here. And when you notice that more and more light is getting added to the moon, and the moon is rising later and later and later. So now the waxing gibbous moon rises in the afternoon. Now, as we approach the full phase, notice that the moon is getting to the opposite side of the Earth. In other words, if you were standing, let's say, at the North Pole on Earth, you'd look in one direction and see the sun, and you'd look in the opposite direction and see the moon. So to put ourselves back in Baltimore, we're just going to watch right now North America is in the night side of Earth. If you look at the inset, and now North America comes around and we're at the full moon. That means the full moon rises just at sunset. See there? So the sun just set and the full moon rose. So let's watch that again. So the sun sets and the full moon rises. That means the full moon transits the meridian at midnight, and the sun is now setting, and because we're now past the full moon, you will notice that the moon rises after the sun sets. So the moon is rising later and later, and it's going to be usually past most people's bedtime before any moon will rise, the waning gibbous moon.
Okay, my students, I wish you benefit from this video. Okay, about the phases of the moon we take before. Today we took tides are changing the height of ocean water. That is the rule of tides. Here is my student page 335. We have a question here. Where all have the people gone? On the line below, but I want an excellent student to read this question. Okay, Muaz Amr, how are you, Muaz? Can you read the question, please?
Yes. On the lines below tells where the moon means have between when the picture on this beach
Yes.
was takes.
When the page was taken. We said that is the high tide. It's the high tide in the picture on this page. The moon would be above the ocean or the other side of the earth from the ocean. We said first, my students, we said that high tide. That means up, you know. So we see high tide, not low tide. You know the tide. What is the tide? The change in the height of the ocean water. Change it in the height of the ocean water. I will try to write for you. Height means change it in the height of the ocean water. You know the ocean, you know the sea. It will go up. It will be high tide. Okay, my students.
I have exhibition.
Okay, well done. Your name is Muaz Amr. You have experiment today?
Yup.
But inshallah, the next session, what you experiment about? But you don't raise your hand. Why?
I raise it.
Okay, no problem. But can we begin the next session because there's some time?
Okay. Open the mic 5 minutes and I said to you.
Okay, inshallah, the next time, the next inshallah period, okay, we will inshallah begin with you, my students. No problem. Okay. Thanks, Amr. So, when the pull of the moon gravity causes ocean tides. The reason here, the pull of moon's gravity, the attraction of the moon, the pull of the moon gravity causes ocean tides. Causes ocean tides, maybe up, maybe down. The type of tide is tide, high tide, and low tide. So the parts of the ocean between the two areas of high tide, the water level is lower, and the low tide occurs when we have all people, okay, occurs when what with each other, high tide and low tide, okay? We have two types here, tide, high tide, low tide. Okay, now that is the high tide. That is the high tide here. Sorry, just the tide. I'm sorry. That is the tide. Just the tide, like that. Okay. So my student here, We'll go to this question. To the high tide we set. Okay. This picture to the high tide. The moon will be above the ocean because the moon will be above the ocean. The moon will be above means up of the ocean. So that's the high tide here. Okay, that is the question in this page. We will draw what the image on this page will look like. Next condition like it's a cycle. You will make image any image if you write according to the video you see. You will make image, draw according to. I will give you. I will leave you 1 minute to write this question in your book, not in notebook. Go.
Mr.
Students.
I am Mu'azzam. I don't finish the writing
This one or the summary?
summary.
But write this first, then I will open the summary for you. Don't worry.
Okay, thank you, Mr.
This is the summary, my students. If you want to write the summary, this is a summary of the lesson today. The tide, the change in the height of the ocean, the pull of the moon. That is the reason of the tide, the pull of the moon gravity causes ocean tide. We can see what is the reason of the tide. I will give you just 1 minute to write or make a screenshot of the right. Thanks for good listening. I wish you understand. Assalamu alaikum wa rahmatullahi wa barakatuh.